All right, good afternoon, everyone. My name is Charles Nebeze, and I'm the Vice President, Business Development and Commercialization with the Center for Excellence in Mining Innovation and also with the Mining Innovation Commercialization Accelerator. I know it's a bit of a mouthful. I'm joined today with my colleague, Lenisa Moodley, who's in business development with me. And today we're going to be hosting Copperstone Technologies, and they'll be presenting on the autonomous robots for hazardous waste site investigations. But before we jump into the presentation that Greg is going to deliver, I just want to let you know that we did have 16 approved MICA projects from our first round. And I wanted just to show you what those 16 were. And we are doing a webinar for each of these 16. So just check our YouTube channel and you'll be able to see those presentations as they go into that channel. Also, for those of you who are interested in submitting a proposal into the next call for proposals, it's open now until Jan 13 of 2023. Please feel free to just point to the screen of your phone and follow the link that you see here, and you'll be able to see the whole entire process. It gives me great pleasure to hand over to Craig Milne, who's going to be presenting to us Copperstone Technologies' approved project on autonomous robots for hazardous site investigations. Craig, please take it away.
Thank you, Charles. I'll just flip my screen on here. And I guess thank you, first of all, to yourself, Charles, and the whole team behind MICA to put all of this together. I know it's very challenging to put together such a large funding package, but it really does help companies like Copperstone move forward for improvements in the mining industry. So Copperstone, we are an Edmonton-based robotics company, and we're on a mission to enable humanity to reach further, to tread lighter, and to stay safer. And so what does that mean? You know, for us, as a robotics company, we're all about accessing hazardous locations and doing that safely. There's some extremely challenging environments in the mining industry, and this is a great example. So that is a tailings pond. So that's where most of the waste generated from the process of mining ends up. It's in a pit like this. This looks like a giant lake, but you can see in this facility, there's actually like a surface cap of foam, which makes this environment really difficult to access for our clients. And they need to get out there to do routine monitoring, sampling work to keep the place safe, really, for the environment. And so tailings are a huge liability and risk for the entire industry. They take several forms. They are typically retained by a dam wall that is also made out of tailings, and they contain all of that waste product. And when there are catastrophes in the industry, they are global events and significant risk for the companies that hold these tailings facilities. The challenge of monitoring tailings really comes in to around human safety. It's hazardous to get out there. Sometimes it's because of the actual chemical nature of what's in the tailings, but it's more often a physical hazard. These are very large facilities, several kilometers across in size. They can be built in extreme weather environments. You know, we all know that the mining industry, mines are typically located in very challenging environments naturally. But combinations of soft mud or water or rocky ground really pose a challenge to access. And so when you put people out in those challenging environments, it drives risk for the industry and drives cost as well. So Copperstone, we think of ourselves a little bit like NASA. We think of ourselves as building robotics for hazardous site investigation. And a great example is the Mars rovers. You know, these are robots that are sent to the most extreme environments to collect samples, to collect information about what those environments look like. And of course, for the planet Mars, it's all about understanding what that environment looks like. So when humans eventually go to Mars, we know what's there. But we use robots in that situation because it's safer and less costly and much less risk than using human crewed operations. So that's what Copperstone does here on Earth too. We send robots into these really hazardous environments. This is a great example. Really hazardous tailings pond, really challenging to access it. And so we send a robot out into the facility to collect samples and to collect information that the mining company needs to manage this facility. This is a very, very large tailings facility that was typically only accessible by helicopter. You could see in that video there was one road that sort of ran through the center, but all of the rest of the area is accessible by helicopter and really surface samples only. This is another great example of some of the robotics that Copperstone provides is being able to access water-based environments. It's okay to do with a boat, but really challenging to do when you've got water-ground transitions or shoulder seasons where water might be higher risk than normal. And so what's unique about Copperstone's robots is we're able to access all of these types of environments, whether they be hard ground, soft ground, or open water. So typically, what's done in the mining industry today to manage tailings, there are a number of specialty vehicles. They're almost always human-operated vehicles. And so, for example, this boat on the left, these people are doing a bathymetric survey. And so they're measuring the depth of water. It's an important requirement. The mining industry needs to know how much water is in the tailings facility. And so they send out several people in a boat with sonar gear to do that work. On shore, there's always a rescue crew available just in case there's a problem. And so then having 5 people on site is an expensive process for the industry and just risk for the people involved. The middle picture is of an amphibious excavator. So it's an excavator that floats on pontoons that give the vehicle some buoyancy. They have some history of getting stuck. There's been some fatalities in the industry, and so they're very dangerous vehicles to operate. The vehicle on the right is a specialty geotechnical investigation truck. So it's a heavy vehicle that's capable of doing some measurements deep underground. There's people inside the truck to operate it, which is always, again, a risk. But as a heavy truck, it's also got limited capacity to traffic on soft ground or snow, and certainly not open water. So Copperstone then has taken all of these needs from the industries and packed it into a fleet of robots. And we call all of our robots as a family Helix. And that's named after sort of the helical flighting that's around these pontoons. So Copperstone has an issued patent on this concept of propulsion. And it's really it's a hollow pontoon that allows the robot to float in water, and a helical flighting that we can turn either quickly to operate like a propeller on a boat if we're driving in water, or we can turn it slowly and we can basically crawl through soft materials like mud or snow. We can even act like a 4-wheel drive vehicle and driving the robot like 4 wheels on a car. And so what's special about what we do at Copperstone then is integrating all of these technologies into a family of robots. And our robots are large because the payloads required in the mining industry are quite heavy. And then we can automate those and operate those at a long distance. This is an example of some of the kind of work that we can do for a client. So I've mentioned like those people in a boat, they were doing a bathymetric survey carrying sonar. And so this is an example of something that we have done for a past client using that robot in the last picture. So we're able to drive with an autopilot-based system. So hands off for the human operators who stay safely on shore. The robot can drive these grid lines carrying a sonar system and build up a volumetric map. So it's the same work that the clients are expecting from human-operated boats, but done completely safely with robots in the facility and people on shore. Our robots can be instrumented with several different payloads. This is an example of carrying an ice drill. So if you need to measure the thickness of ice in the winter, really important if you're building an ice road, or if you're putting heavy equipment out onto a frozen tailings facility, for example. We can also do several physical characterizations. This robot has a series of sensors on board that can do physical profiling of water. This is a really important set of techniques. Our clients are interested in geotechnical measurements. So really trying to understand how firm or how soft the ground is. It's important as the tailings facility settles. And so this tool that my colleague's holding is called a cone penetrometer. And so it's actually a long stick that we push into the ground with instrumented sensors in the tip, but just below his hand there. And those sensors are able to measure the bearing strength of the ground, which gives information to geotechnical engineers about what type of material is underground. And we push that from a robot that looks like this. It's about 1,000 kilogram robot. And it's a prototype that we've been operating for several years in the mining industry. And so we know there's lots of need for it from our clients, but they're all telling us that it's too small. It's too small because at 1,000 kilograms, it can't push heavy enough or can't push deep enough. And that's really what our clients want. These tailings facilities can be, typically 30 meters, they can be 100 meters deep. And the robot in that middle picture, our prototype that we've been operating for several years, has a limitation of only about 4 meters. And that's, for our clients, it's interesting, but it's not interesting enough. And so they've asked us, come back with something bigger. And that's where we approached MICA and said, we could use some help in funding this scale up of a robot to do geotechnical investigations. So we know the need exists. We know the engineering capabilities of what our team can do. And now we need to put it into a really large package. And so here's an artist's picture of what we're going to be building. We'll soon to have some engineering drawings to show off pretty quickly, but we plan to build it again around the screw drive propulsion system, something that we have really specialized in and gives us that access to all of those environments, and then build all of the specialty tooling and payloads on board that our clients can access deep tailings facilities, at least 30 meters, and be able to push with enough strength that we can actually get really interesting samples for them so that they can understand their tailings better. I want to show you actually some other pictures. These aren't ours. These are what other companies are doing in the industry, just to show you the direction the industry's headed. So this is a great local company, Greg's they're actually a California company. They've got a British Columbia outfit with a similar name, but they're using a coiled system to be able to push tools into the ground. And so there's opportunities for us to partner with companies like this to accelerate the development of what we're doing. They've obviously built a remote controlled tracked vehicle to do it. And so it's got all of the limitations of a tracked vehicle, but you can see that the industry is really pushing for these unmanned solutions. This next video is from a Dutch company called Fugro. They built a giant machine, again, remote controlled, although there's a human operator nearby there. The system is built to have it unmanned. Again, a tracked vehicle, and you can see the marks that it leaves in the ground. So it's not very good at soft soils. And we know from direct experience with a client that this vehicle can have challenges in soft material, of which tailings are a prime example. So they have again a coiled system that they can push tools into the ground with. So those are all very interesting points for us to take note of as we develop our big robot. It really shows where the industry's headed. But this is the kind of terrain that most of our clients are looking for. This is a tailings pond up close. And what you can see is that there's patches of water, there's patches of soft ground. And those last two vehicles I showed you, they will not work here. They get stuck. And so that's where our specialty screw drive vehicles come into play. So we can get out into this kind of facility and operate. I always like to share this cartoon. This was something we did with Vale. They're a Brazilian mining company, largest iron mining company in the world. They had asked us to demonstrate the capability of that 1,000 kilogram prototype robot that we have. They had this exact same problem where they need to be able to collect geotechnical data without putting people in harm's way. And so what we were able to demonstrate for them is that we were able to take our robot, access their facilities in a way that we didn't have any risk to people. And we were able to push tools into the ground, collect samples for them in a way that they weren't able to do previous to us. And so again, that helps us really understand that the market space for what we're developing exists, and the technologies are being developed primarily by Copperstone with the support of MICA. So really appreciative of that support. All of this information then, using robotics to collect this kind of data for our clients, it enables them better information. And with better information, they can be more proactive about managing their tailings facilities, both for security and risk mitigation of any events that may occur on tailings, but also in terms of the settling and reclamation efforts. The more they know, the better that reclamation effort can be. So this is Copperstone in a nutshell. We're 25 people here in Edmonton. We have currently an 8,000 square foot manufacturing facility. We're looking to grow our physical space so that we can continue building larger size robots and continue to grow the team. So thank you very much for your time and attention today. Turned over to Charles for some questions.
Awesome. Thank you so much, Craig, for that presentation. And you know what, you're right. You guys are definitely boldly going where no one has gone before. Just to pick up on your space Mars rover example there. And thanks for showing the videos. And also thank you for showing the scale of the competing machines that are in this space, compared to what you have. That was really, really good for us to get that visual on what it is that you're building exactly. So my question has to do with communications. And I don't know if you say this already, but could you tell us, for people that sort of want that real-time monitoring, how does your technology communicate with things like, Wi-Fi networks, radio frequencies, and how does it communicate with things like private networks, where you may have LTE? Maybe just comment on that piece, on how that communication piece works.
So our robots are built with several redundant radio systems on board, and we want the redundancy so that we can communicate over several different channels for just to make sure that we maintain communication with the robot at all times. And so we can communicate over 900 megahertz radio, Wi-Fi networks, or cellular, as you mentioned, LTE. We're even looking into things like Starlink. That's a fairly new opportunity for us. We do need to be able to transmit large amounts of data. Small amounts of data are able to control the robot and get feedback from the robot in terms of its operating performance. But as we start to transmit things like video information from the robot, the bandwidth gets pretty high. So that's where we look to both Wi-Fi as well as cellular radios as well. And then your question about security is, we look to ensure we have secure protocols as we're transmitting data over the internet or over Wi-Fi.
Awesome. Thank you for that. Okay, let me turn over the next question to Lanissa. Lanissa, please go ahead.
Hi, Craig. Thank you very much for that. I liked the videos and the imagery. Very cool. I don't know if Charles mentioned, but tailings is such a big focus now, and so technology like this can definitely make a big difference for the industry the world over. I was wondering about the runtime on the batteries. So what would happen? Would it happen if a robot gets stuck?
So the runtime on the batteries, it depends a lot on the type of material we're driving through, as well as the scale of our robots. I didn't mention, but the smallest robot in the videos you saw there is about the size of a golf cart. So it's actually still fairly large to begin with. It can operate for about 3 or 4 hours on a full set of batteries. And then we bring the robot home and just change the batteries. We just swap them out, and then they can be recharged off-site. As we get into bigger and bigger scale rovers, like the robot that we'll be building with MICA's support, we are considering alternative power sources. There'll always be batteries on board, but we might need to look to things like hydrogen power as a way to augment the energy on board. Otherwise, the batteries get substantially large and very expensive as well. And so, in terms of running out of battery life and getting stuck that way, that's typically not a concern. We've got good battery monitoring on board the rover. We understand its power requirements, and so that gets relayed back to an operator. So there's always a large margin of safety to bring the rover back home before all of the energy is discharged on the system.
I see. And you talked about mining companies wanting these robots being bigger. What was the reason again for that?
Well, really, it comes down to being able to push and to drill deeper and harder. And so, you know, I've shown a couple of videos with that tool that they're pushing into the ground. That's one of the prime things that they use to understand what's in the tailings pond. And so being able to push that heavier just really needs a heavier vehicle on the surface to do that.
Gotcha.
Awesome.
Thanks.
Awesome. Thank you for that question, Vanessa. Certainly, you know what, I think when you showed us a picture of some of those tailing ponds being really wet, I think, you know, kind of goes to show that some of those machines will definitely sink, you know, especially the ones that look like front-end loaders with a tread that is used for moving heavy materials. So my next question is about the speed of deployment of your solution. And this is a question we get often from mining companies, you know, who are looking at solutions. So maybe you can just comment from the time when you sort of do an assessment of a tailing site or a mining site, how fast can you deploy your location? And also, can you maybe comment on where on the planet you are capable of deploying, just so that the mining companies have an idea on where your solution can be offered?
Yeah, so, you know, as long as we have a robot in house and we're ready to go, you know, we can deploy a robot very quickly, like essentially same day if the robot's ready to go. And we've had to do that in, you know, in quasi-emergency situations where we need to get to site quickly. Typically, the slow end is on the mining industry, just making sure that we've got all of our paperwork in a row. And so, you know, we're pretty good at that on our end. You know, all of our field operators have, you know, they're well trained. They've got safety certifications, you know, supervisory tickets, MSHA training, all of the things that are required, and then there's site-specific training as well. The robots are generally quite quick to deploy, and they're also easy. They're intended to be easy to work with, and so they all travel on small flat deck trailers pulled by pickup trucks. We can put them in a sea can. We can ship them across the country, across the world. We shipped a robot a couple of days ago to Brazil, so we'll have a field team that goes down there in a couple of weeks' time and unpacks that when it arrives. It actually went by air as well, so very quick to deploy.
That's impressive.
Yeah.
Pretty cool. Lenissa, another question for you?
I'm not sure if you talked about use cases outside of the mining industry. Did you?
Not yet, but we're looking at all, you know, we're interested in all sorts of things. You know, the first most adjacent thing for us, industry for us, is really environmental monitoring. There's lots of opportunities to help access challenging environments, just to help with environmental compliance and monitoring. There's also lots of interest in search and rescue capabilities of the robot. If we can get into you know, beaches and floodwaters and, you know, snow or thin ice operations where it's very hazardous for other searchers or rescuers to access, then there's a good opportunity for the robots to do some work there.
Okay, thank you for that. It's good to know that you're looking at areas of interest as well. I have kind of a two-part question for you. The first question is, are there any toxic tailing environments where your robot just doesn't go? And then the next question is, you know, to do with your business model, you know, are you selling the robots or are you doing it as a service? Maybe you can just clarify those two things.
So to the first point, toxicity to the robots, really, there's not. You know, most of the robot mechanical systems are made out of aluminum, and extremely low pH is bad for aluminum. And so, you know, if we know we're operating in an extremely low pH environment for a very long period of time, we can build the robot out of other materials. We've actually 3D printed and produced an entire plastic robot before. You know, stainless steel, titanium, those are other options as well. So, but in a nutshell, no, like the robot is really well designed to operate in all temperature extremes. You know, it can operate where there's baseline radioactive materials, all those kind of environments. And then to our business model, we've typically operated what we call robots as a service. So the mining industry needs a discrete project to collect information. And so we have a field team that is, I mentioned, got all of the training both on the robot as well as in the mining industry, that we can take a robot out to site, collect that data for a client, and share that with them. And that's quite easy and quite effective. And then there's no risk to the mining company in terms of having to purchase or maintain a robot. There's no risk in terms of what you're getting. We have the expertise to do what we say we're doing. There have been situations that we're getting more and more into now where clients, they really need a robot all of the time. Could be every day, really doing work for them on site. And so in that case, it makes sense for everybody to consider more of an asset purchase sale, that robot mining company purchasing the robot as a piece of equipment. And so that's something that we're open to. And then what we do in that situation then is we would sell a robot, send a field team down to do installation and training and make sure that the mining company has all of the operators on site to do it safely as well. And then with support after the sale as well.
Awesome. Thank you for that. So it looks like the worse your tailings are, the more you need this robot, right? And I kind of like that. That's really good. And also your business model, I think it looks very flexible. Where there's a need to go as a capital, there's the opportunity, and where you need to stick to OPEX as a pricing model that also works great. Yeah. So Craig, what I'm going to do now is before we end off, I just want to give you the floor again. Is there any parting words you want to say to this ecosystem that we're in before we end our presentation? Please go ahead.
I've been really impressed actually with the mining industry in general. I'm fairly new to it. For me, the mining industry has been a 4-year journey of learning, and the amount of change that I've seen just in the 4 years, with the focus on tailings, the focus on better risk mitigation, and even recently, really ambitious targets for GHG reductions and reprocessing of tailings. I'm quite happy to be in this industry and quite proud of the work that we're able to do to support the mining industry. So really looking forward to working with everybody, and happy to entertain all sorts of weird and wonderful ideas you might have in terms of how robotics can help you manage your facilities better.
Actually, thank you for the presentation, Craig, and thank you for those parting words. Talk about crazy ideas. Maybe having a swarm of these robots, just all over the place would be also pretty cool to see.
You bet.
All right, man. Thank you,
Charles.
Really appreciate you. Take care.
Okay, bye-bye.